Okay, let's go. So I'm here again. Probably you see myself here in a few minutes ago creating the first smart contract with you. But now I'm here with Harry to
Hello.
talk about Chainlink and how to build secure cross-chain applications with Chainlink CCIP. So my name is Solange Gueiros. I am a developer advocate. I teach developers the basics of smart contracts and also how to use all the Chainlink services. And you can call me Sol. You can find me around.
So Sol came all the way from Brazil to be here. And my name's Harry. I manage the DevRel team at Chainlink, and I came all the way from Adelaide to be here. So definitely not as far as Sol.
So is this. This is our bounties here, our prizes. If you would like to use the CCIP, the two best projects you win 2,500 each. And also we have, if you'd like to use all the other Chainlink services like functions, data feeds, data streams, proof of reserve, VRF, automation, all of this, we are getting the 3 best projects. This amount is so hard to say, I cannot say that, but you can win one of that as well, okay? And this is the presentation, so this is the most important slide for you, so get this now. I know that I have more QR codes, but you can forget the others, but not this. Yes. And so, first of all, what is an oracle? We used to say that an oracle is a way that you can connect with everything that's outside the blockchain, or even when you talk about CCIP, to have connections between blockchains. So an oracle can be like a temperature or the weather that is nice to be a hacker this weekend, or the sports, or everything related to data as well. And I don't know, it's so big. I mean, it's cutting some part of my code, okay? Only to you know. But is this, when I talk about oracles, if you have only one source getting the information from the outside world, this can be risky because this can be compromised, can manipulate this information. So the best solution is to have a decentralized oracle network. It means that you have more than one operator, one node, getting the information and getting a consensus on that in order to save this information inside a smart contract. So the most important part is to be sure that your smart contract is safe when you are input in a smart contract. And when you talk about Chainlink, we have different services. Like when we talk about data feeds or data streams, we are talking about especially quotes, like how is the price of it in USD? This can be one of this information. When we talk about functions, this is so amazing because you can create a JavaScript code to call any external Web2 API and then bring the result to your smart contract and use inside your contract. And also, if you'd like to use a VRF, it can be used to generate random numbers, because if you add the rule to generate the random number inside the smart contract, this is so risky because can be manipulated as well. Or if you'd like to use automation, imagine that you have a function in your smart contract that must be executed with some conditions, your business rules. So you can create another function to check these business rules, and automation can do that for you and execute what you need to execute. And also the proof of reserve is used to prove reserves that is outside the blockchain. Or imagine that I am on Ethereum, I have the wrapped Bitcoin, and I'd like to know the reserve of the issuer of this, that the BitGo on the Bitcoin network, or even from a real bank to know the balance of an account, okay? All of this that I told you are in our developer portal. So if you go to the developer portal, you can get all the information related to each of these services. And it's important to you know that blockchain is Chainlink is blockchain agnostic. Chainlink is not a blockchain. Chainlink is a set of services. And we have these services on Base. We have these services on other networks as well. Ethereum is the base of everything, but we have the others as well. And feel free to implement what you need to have. And let's talk about CCIP. This is the cross-chain interoperability protocol. And I'm starting doing a demonstration with you. And after that, Harry, you explain better what I did. Okay? And we need this time in the middle. So first of all, remember that the blockchain, it's isolated. The blockchain, they cannot communicate with each other in a natively way. And think about a high-level architecture. You are the user, and you are interacting with a smart contract that I will deploy now with you, and I will use Fuji on this moment. I tried to use Base, but I didn't have time to set up everything. I know that we have Base here, so if you deploy yours using Chainlink and Base, you can own both prices. This can be good for you. And I'm creating the smart contract now. My smart contract is interacting with the router. The router is a smart contract made by Chainlink. And then this is made the communication, making the communication between the other network. My goal is to send some USDC from Avalanche Fuji, and this USDC will appear on Ethereum Sepolia. This is what I'm doing now with you. And when we talk about CCIP, I'm transferring a token now, but you can send any kind of message. And imagine that this message can be calling to call some function in another smart contract. So I can call NFT and mint an NFT in another contract. Or I can call any function in another smart contract that is in the destination blockchain. And merging this, I can send a token and say what I'd like to do with that token in the destination blockchain. This can be really amazing. And this is, let's use CCIP to transfer USDC. And I'm doing from Fuji to Sepolia. You have in my presentation, so you have all the requirements. You understand how to get the USDC. Now I must do more a demonstration. I must be fast, sorry. And this is the smart contract that I'm using now. And at the end, I will show how this is working on the CCIP Explorer. So here I am. I am on Remix now. This is my smart contract. It's done. And I'm deploying this smart contract now, but I'm wrong. I am on Sepolia. So let's go to Fuji. Change here and go to Fuji. Here I am. Now I can deploy my smart contract. And the best way to prove that this is working is doing live with you. It's a dangerous way, but I like that. So I have the smart contract now. When I'm doing this kind of transfers, I must pay fees. And I can pay fees using the native token or using the link token. I will use link token. And all the fees I'm paying only on the Cersei blockchain. So imagine that I have a transaction on Sepolia, but I'm pay everything here on Fuji. So first of all, I'm sending some link to my smart contract to be sure that I can pay the fees. So tokens, I have a link over there. And send 5 links to my smart contract. Is that. Okay, now I'd like to transfer USDC, so I must allow my smart contract to use my USDC that are in my wallet now. So I'm getting the address of my contract, going to Explorer, and I am exactly on the USDC coin. Here I can go to this right as a proxy, and with my wallet connected, I can approve this. I did this a few minutes ago to another contract. So this is my smart contract now. And this is the value that I'd like to have. This is 1 USDC because I have 6 decimal places over there. So 1 and 6 zeros. And it seems that this was the last one. No, I think I can do this now. Let's be sure that it's another. It's 6327 63. Yes, it's the new one. So right. So remember that I'm approving my smart contract to use my USDC to transfer from my wallet to another place. Okay? And when I have these two done, I must wait this. Then I will be ready. I think it's done now. Then I'm ready to call this function transfer USDC to Sepolia. And over there, I will use my own address. This is my address again. The amount will be 1 and the 6 zeros. 1, 2, 3, 4, 5, but this. And transact. And confirm that. And I'd like to get this transaction now. Failed. Why it's failed? Ooh, what I did wrong. I did something wrong. Harry, would you like to explain your part and then I will discover what I did wrong? Because something's wrong.
Sure. But you're not going to bring up the diagram though, are you?
Yes. And here you are.
Yeah, thank you. So while Sol has a look at that, I'll try and explain what this cool but an oddly satisfying animation means and how you as a developer interact with CCIP. So basically, you as a developer, you have a smart contract or a wallet on your source blockchain, and you want to send, in this case, some USDC to your destination blockchain. So on every blockchain, there's a thing called a router contract, which Sol mentioned, and that's all you ever need to interact with. So here we have a router contract on the source, router on the destination, and then everything between is the inner workings of CCIP, which I'll just briefly go through, but you don't actually have to worry about it. It's all kind of abstracted away. But essentially, when you want to send data or tokens or both, such as USDC, you interact with a router contract. The router contract will interact with this thing called an on-ramp contract, which will also potentially interact with a token pool set of contracts. So in this case, USDC. So in Sol's example, the on-ramp's going to burn USDC on the source chain, and then it's going to emit some events to the blockchain there. And then we actually have 3 different Oracle networks that monitor CCIP. So we have a high level of security here. So the first thing that happens is the committing decentralized Oracle network will have a look at what was written here, and it will bundle things up together and create what's called a Merkle root on the destination chain. It says, hey, this is what happened here. But it doesn't do that until full finality has been reached on the source chain. So in some cases, it might have to wait a few minutes or a couple minutes, depending on what the chain is. Once that happens, we have this separate thing called the Risk Management Network. So this is basically another Oracle network that oversees all of CCIP and makes sure there's nothing dodgy going on in any of the transactions. And it has the power to either bless transactions or curse them. So when it blesses them, it's like, hey, everything's good, you're good to go. If it notices something bad, it'll curse it, and that can potentially pause everything. So in this case, it'll see what was written here in the Merkle root. It'll rebuild all the transactions here, do a bit of a comparison and say, yep, all is good. I now bless these transactions. Once that's done, the executing Don will basically take the transactions again, and it will do its own checks as well and create what's called a Merkle proof. And once it's done its own checks and it says, yep, everything's now all good, it will actually execute the transaction on the destination chain for you. So it will go to the off-ramp contract, potentially mint some tokens. In this case, it will mint USDC, and then it will go to the router contract, which will then call or send the tokens, in Sol's case, to her wallet address. So that's kind of the end-to-end flow.
Yes, let's come back a minute and then you talk about the simulator, because I don't know if it was only failed because, no, now you failed because I didn't. So what I must do now, I will do this again. And now I'm authorizing more. I'm authorizing like $10 to transfer. You can see that. And probably I must wait a bit between this and the other. But what I like to do now, I have some, I can see here the outlets. So the problem was the outlets. You can see that it was not authorized. Now it's authorized. Also, I can see my balance here. And I can see the balance of link. I don't have USDC here. This is good. I should have USDC here. Let's see. Yes, I have. So now should work. Let's try again, and then Harry talk about the other, the local simulator, because now you must wait for me and 3. Yes, this is right. Cross fingers. Okay, confirming. Probably I did so fast and it didn't confirm it yet. Yes, now is right. So you can see over there that I have this transaction. I'm copying the transaction ID. And if I go to the CCIP Explorer, I can check, no, not that. I can check the transaction, and the search is finalized, and is going to Fuji to Sepolia 22 seconds ago. And while we are waiting this, Harry talk about how can you do this locally to not wait like I'm waiting now.
Sure. So as I said before, because of the having to wait for finality and CCIP, you might be waiting 5 minutes for a transaction in some cases, or more. What we actually built a dev tool recently that we just released called the CCIP Simulator, which allows you to build with CCIP on a hard hat or Foundry local network, or even in a Remix VM. So transactions will be instant. You still use all the same APIs that you would use on a testnet, and allows you to iterate and build on your code quicker. So if you want to use it and test it out, go to our GitHub Smart Contract Kit, or Google Chainlink GitHub, and it's pinned here called Chainlink Local. Yeah, definitely recommend checking that out.
Exactly, because I'm curious, sorry. Yes, we are still waiting, so let's come back. It's blessed now, like Harry told before, now it's blessed. And I think all of this, you can see later some parts of what we are doing. These are some use cases.
Yeah, cross-chain DeFi is very popular at the moment. Lots of opportunities there if you're looking for something in the DeFi space, especially if you combine it with data feeds as well. You can be eligible for 2 prizes. Cross-chain gaming starting to bubble up too, sharing game state between games, and really anything where you can kind of imagine something that having a shared state across with an application across chain, so cross-chain governance and things like that as well.
So how was this token, how this working with the token, with the USDC or in tokens in general?
Yeah, so CCIP supports a few different token transfer mechanisms. So you can have burn and mint, where tokens are burnt on source chain, minted on destination, which is what happens with the USDC. Or you can have lock and mint, where they're locked, not burnt. And there's also a third one, which is not officially supported on testnets yet, which is why it's not here, which is lock and unlock.
Is this, and how I'm paying this?
So you generally just have to pay once on the source chain, and you can, as Sol said, you can pay in native, the gas token, or in Link.
Perfect. And this is all the references related to what I did?
Yeah, and just to finalize on the prizes, we're finishing now because I know we're at time. Best use of CCIP, 5,000, and then 2,500 each for the next 2 best. And then for any other Chainlink service that you use, if you need data, API calls, automation, randomness, proof of reserve, we have 1666 for the 3 best projects. So yeah, if you want to combine Chainlink services, you'd be eligible for both prize pools. So if you have the time, I think that'd be a great idea.
Yes, let's see how is my transaction now. Cross fingers. Yes, success.
Hey.
Yoo-hoo!
Woo.
So let's show the result for you. So I'm going now to Sepolia again. And my wallet was empty. I could show you this before to you. But if I came into the tokens part, I know that I have 2 USDC now. Oh, so I did one when I was waiting over there. And now I did another here, exactly here. And this is really amazing because you can see that I have my USDC on Sepolia now. And if you came back to the transaction here, and you can see that it was 1 minute ago, all good, and I transferred 1 USDC. And is this, do you have more time? I think no. Yes? No. Okay, thank you so much.
Thank you.
We are in the booth if you need something, and we can answer questions outside.